Welcome everyone to this month's webinar on 4D and how it can be used to improve project outcomes. This is actually one of my favorite topics to discuss, so thank you for joining me today and allowing me to present this topic. We have a lot to cover in this webinar, so let's get right into it. My name is Barry Cymbaluk. Any of you that know me well know that I'm not big on talking about myself. I'll just keep this introduction quick. I started out in the industry with boots on the ground, earning 2 Red Seal trade tickets. I worked my way up over time, holding various positions such as workface planner, scheduler, supervisor, ultimately trending more towards the project management realm these days. I'm passionate about adopting new technology like 4D, as well as processes such as advanced work packaging to improve productivity on construction projects. So just a quick overview about myself. So what exactly is 4D? 4D is a process that links the construction activities represented in time schedules with 3D models to create a real-time graphical simulation of construction progress against time. So what does 4D offer project stakeholders? 4D offers project stakeholders and participants the opportunity to effectively visualize, analyze, and communicate issues about sequential, spatial, and temporal aspects of the construction progress. For today's webinar, we are going to use a typical oil and gas module as the example. Although this example is rudimentary, I just want to point out that in our experience, the larger or more complex a project, the more value 4D offers. At Trillium, we have successfully implemented 4D on projects from $100 million to a $10 billion mega project. So we can see here in the animation that on the bottom left, we've got our tasks with our start and finish durations, and then we've got the Gantt chart on the bottom right. And on the top, we've got our 4D model. On the top right, we've got our timeline, and on the top left, we've got our appearance profiles. So the way we have our appearance profile set up for this example is when the task is in progress, it is green in the 4D model, and when it's complete, it's gray in the 4D model. And these are completely customizable, and we'll get into that into further detail later in the webinar. There are a lot of misconceptions and different definitions on what BIM is. We don't want to go down that rabbit hole in this webinar, but it is important to have a high-level overview of where 4D situates itself in the BIM process. In layman's terms, Level 2 BIM is achieved by using 3D design software such as Revit, combining the different discipline 3D design models into a federated model, and working collaboratively using a common data environment. With BIM aside, just remember the bottom line is, if you have a 3D model and 4D software, you can start to reap the benefits. In the previous slide, we talked about BIM and how to achieve Level 2. We also talked about a common data environment. So the common data environment, is also known as a CDE, is the single source of information used to collect, manage, and disseminate documentation for the whole project team. Creating this single source of information facilitates collaboration between project team members and helps avoid duplication and mistakes. While this may sound complex on small projects, the common data environment might simply be common folders on a server, or may use a free web-based file sharing application. One of the common questions we're asked is what software are we using for 4D and BIM? At Trillium, we are software agnostic. We try and use the software that best fits our clients' requirements and needs. With that being said, for 4D software, we really like the capabilities of Fuser Construction Pro, Bentley's Synchro Pro, and Alicosoft Power Project. Some popular choices for design software include Revit, ArchiCAD, and for a common data environment, we like Quadri by Trimble and Synchro by Bentley. We can produce a 4D model in 2 different ways. We can attribute the tasks within a P6 or MS project schedule to the 3D model, or we can create tasks based off of the 3D model. This is referred to as model-based scheduling. Alright, so in the previous slide we talked about the 2 different ways a 4D model is produced, with one of the techniques being by importing a schedule in a 3D model and attributing the tasks to the 3D model components. So I'll go ahead and demonstrate that now. So we've already imported our schedule, and we've also imported our 3D model. And we can see here within the schedule under vessels and exchangers that we've got install level 1 vessel. So in the 3D model, we can clearly see here that there's a level 1 vessel. So we'll go ahead now and select that. Then all we have to do is simply attribute it to the task. Assign selected resources. So there we go, done. The other way to develop a 4D model is to use the 3D model as the basis for developing the schedule. And just to reiterate, this is referred to as model-based scheduling. So I'll go ahead and demonstrate this now. You can see here that we've imported the 3D model, but we have no schedule. And I'll use the first level vessel again as an example. So we can see it here, and we'll go ahead and create a task based off of that. So we'll just call it first level vessel. Perfect, so it automatically populated a 1-day duration, which is probably about right, and a start and finish date. They're both listed here. So now all we have to do is select the vessel and then assign it to the new task that we've just created. So there we go, done. Model-based scheduling is an extremely effective way to develop a schedule, as the likelihood of there being any gaps in the schedule is significantly reduced. Some examples of gaps identified on past projects that I've worked on include a 12-inch high concrete retaining wall that went all the way around the perimeter of a commercial building. It was not present in the schedule. This concrete retaining wall is highly visible in the 3D model. It would not have been missed with a 4D model-based schedule. If your project schedule is missing a significant task, a task that would take over 40 hours to complete, how would that affect the construction completion date? It would probably alter things significantly. So the big question, why 4D? Several studies indicate images improve our ability to comprehend information. The human brain processes images 60,000 times faster than text, and 90% of information transmitted to the brain is visual. Since we are visual by nature, we can use this skill to enhance data processing and organizational effectiveness. A Gantt chart is a type of bar chart that illustrates a project schedule named after its inventor Henry Gantt, who designed the chart around the years 1910 to 1915. I am sure that a lot of us present on this webinar have tried to assimilate a comprehensive Gantt chart in the past, and I bet the struggle was real and probably caused some disengagement or miscoordination amongst the project stakeholders. Unfortunately, the price to pay for poorly planned or out-of-sequence work can result in execution risks and injuries, as well as quality issues. Naturally, there are a lot of benefits when it comes to the use of 4D. For this webinar, I created a list of 6 benefits in respect to 4D planning. First on the list, we have the ability to see what you are constructing. Second on the list, we've got the capacity to quickly and easily communicate the schedule to all stakeholders. And third on the list, we've got the ability to identify problems that may not be visible via traditional schedules. Fourth on the list, we've got the ability to run what-if scenarios to assess the feasibility of the execution strategy and find the best solutions. Number 5 on the list, we can see the impact in the 3D view as we update the schedule. And finally, number 6, we can optimize the budget by ensuring accurate scheduling. Alright, now we can jump into the fun stuff. The following is a list of some of the capabilities of 4D, and these capabilities can improve project outcomes. So we've got status visualization on the list, model-based progressing, path of construction, congestion, what-if scenarios, critical if planning, equipment optimization, advanced work packaging and workplace planning, and of course we've got safety. So let's take a deeper dive into each one of these items on the list. So one advantage of 4D is the ability to color code the model. In this example, which is the exact same example as we used in the 4D animation example, is work that is in progress according to the schedule is green, and work that has been completed is gray. Another popular route is using different colors for different disciplines. Or if you're using advanced work packaging on your project, you could color code your work packages. In project management, the critical path is the longest sequence of tasks that must be done to successfully complete a project. Identifying the critical path is important for planning and scheduling because it determines the total duration of a project. The tasks on the critical path are known as critical activities because if they're delayed, the whole project will be delayed. Using 4D software, we can calculate the critical path and then visualize that data via the 4D model. This allows teams to better control critical activities, set up project milestones and deliverables, and set stakeholder expectations related to deadlines. This is actually one of my favorite features of 4D. We can apply rules of credit to components within the 4D model. This feature can visually update stakeholders on the progress status of various departments on a project. In this engineering progress status view, we can view the 4D model and clearly see which structural pieces have been issued for construction. Remember, job site coordination is improved through visualization. I provided another example, and this example pertains to procurement progress status. Again, this example is for structural steel, and we can see the subcategories include delivered, late, not ordered, released, and shipped. Imagine being an ironworker supervisor and being able to pull up the model and visually being able to confirm the status of your material and plan your day accordingly. And last but not least, I provided an example for construction progress status, and to keep everything congruent with the last two slides, I used structural steel as the example discipline. For this instance, structural steel components are highlighted in maroon if they have been received by the crew, orange if they have been pre-assembled on the ground, blue if the components have been erected, light blue if those components have been welded or bolted up, and green if the work is completed and has been turned over to quality control. This feature allows construction crews and departments, such as quality control, better visibility when it comes to planning their work. It also allows for a more accurate and granular way of reporting progress, which we will talk about next. Utilizing technology that is readily available today, foremen can be assigned an intrinsically safe tablet that will allow them to access the 4D model as well as documents such as drawings from the common data environment. As well, progress can be updated using the tablet and 4D model, which is linked to the schedule and automatically updates the schedule. This feature keeps progress accurate and instantaneously up to date, and essentially reduces the need for quantity surveyors. When I think about past projects that I have been a part of, I realize how having this ability would have reduced a lot of headaches and improved efficiency. For example, I have been in the office when a piping superintendent spent almost half an hour simply looking for one piping isometric amongst literally multiple binders and thousands of drawings. Another example, when I was a foreman on a large project, I spent upwards of an hour a day simply completing paperwork to update my crew's progress for the day. This is all valuable time that could have been spent in a more productive fashion. Here is a scenario that illustrates a lack of planning and coordination amongst trades. Unfortunately, a scenario that I have experienced firsthand many times, as I'm sure a lot of us here today have as well. In Figure 1, ironworkers have installed the second platform steel, highlighted in purple, before allowing the boilermakers to rig in and set the vessel located on the first level platform steel. Because of lack of planning and coordination, the ironworkers will have to remove the second platform steel, which is considered rework, and allow the boilermakers to rig in and set the first level vessel. According to the article, Learning Practices as a Tool for Quality Cost Reductions in Construction Projects, published in the journal Quality, Access to Success, rework can often be as high as 5% of the contract value of a given project. This means it costs $250,000 worth of rework for every $5 million spent on a job. 4D is a powerful tool to visualize the path of construction, improve constructability, and reduce rework. A proper schedule allows 4D simulations to influence the spatial constraints for workers and protect them from possible accidents. Labor resourcing and placement can be realized long before the workers get there, allowing supervision to mitigate high congestion and maximize productivity and equipment utilization. The what-if scenario analysis is a project management process that evaluates different scenarios to predict their effects, both positive and potentially negative, on the project outcomes. Let's take a look at this what-if scenario that I created for this webinar. So the question is, what if all the vessels and exchangers for the project arrive on site at the same time? Will there be room for everything in the proposed laydown yard? If not, can we change the ETA on the material? Or do we have to look at creating another laydown area? We can clearly see from the 4D model that indeed, all of the vessels and exchangers do fit inside the proposed laydown area. It's a simple example, but you get the idea. And keep in mind, this scenario is completely scalable. Another capability of 4D is the ability to plan critical lifts. Here is an example of a dress rehearsal for a critical lift that we have put together in the past. A 4D dress rehearsal reduces the time required to review and challenge the schedule by providing a dynamic visualization of any spatial or sequence constraints in the construction schedule, thus enhancing communication and coordination between all disciplines. Equipment resources can be added to a 4D schedule to show the most efficient placement and which human resources will be utilizing the equipment, optimizing the equipment plans. In this example, the project is in a remote location with very little staging area available. We were able to use 4D to optimize the delivery of the modules and confirm visually which cranes on site would be available to complete the module install. Advanced work packaging and workface planning is being executed on a lot more capital projects these days. With the help of 4D, we can now delineate and schedule those work packages. In this example, we have illustrated what an advanced work packaging compliant Level 3 schedule looks like for construction work packages. Research has stated that the link between planning for safety and work task execution is often weak, proposing that 4D technologies can further improve safety on site by a collaborative approach to construction planning, in addition, providing advanced visualization methods to illustrate site safety plans and procedures. 4D allows us to conduct virtual site walkthroughs, locating high hazard areas, or even to conduct mock drills. Some examples that come to my mind is having a construction crew locate muster points and eyewash stations virtually rather than simply pointing them out on a plot plan. As mentioned in the previous slide, with 4D software we can conduct virtual reality safety drills. And keep in mind, this can be created for any job site. Projects with existing infrastructure can be 3D scanned and loaded into the software. I just want to give a quick shout out to Cymbaluk Tech, the makers of Fuser Construction Pro, for allowing me to use their video to demonstrate this safety capability. One of the main outcomes of a 4D model is the ability to develop specific animations that project stakeholders can use. In this example, we baselined the schedule and created an animation that shows the planned progress versus the actual progress. The purpose of the look-ahead schedule is to plan labor activities and goals for the applicable time period. In this example, we created a 2-week look-ahead animation that illustrates and lists each construction task that follows the 2-week period at the point in the timeline. If you are a project owner or a construction company and are looking to implement a 4D program, I highly recommend that a 4D execution plan document be created. This will help define the requirements, the expectations, and the deliverables for the program. Some items that should be mentioned in this document include the file types that are required, such as Revit or federated model in a Navisworks format, how often animations should be produced. It's also important to define the work breakdown structure of the metadata within the 3D model, and that will help improve the efficiency of the attribution. You will also want to list which capabilities of 4D you would like to focus on for your company. Keep in mind this list is not all encompassing. I just threw out a few ideas just to help get the juices flowing. I have been talking with a few project managers and project owners lately, and an interesting point continues to surface. A lot of project owners are awarding the work to companies that are, well, obviously well priced, but the deciding factor that determines which company will be awarded the work has come down to the companies that have used 4D to demonstrate visually how they will complete the project. It's just something to keep in mind. Research has shown that the successful implementation of 4D planning results in 5% savings in cost growth, 4% savings in schedule growth, and 65% reduction in rework. In the path of construction scenario slide, we mentioned rework can be as high as 5% of the contract value. So to reduce rework by 65%, that equates to some significant cost savings. Well, that concludes today's webinar on 4D and how it can be used to improve project outcomes. I just want to thank everyone again for joining me today. I touched on a lot of topics, and I'm sure it was a lot to take in such a short period of time. Fortunately, though, we have time for a few questions. Feel free to ask your questions in the chat box, and I'll try and answer them as we still have a few minutes remaining. Just in case I'm unable to answer all of the questions today, don't worry. I will reach out personally and ensure that your questions are answered. If you're interested in learning more about 4D or our services, feel free to check out our website at www.trilliumgroup.io. Okay, so it looks like we have one question here. The question is, what if there are tasks in the schedule that can't be correlated to any components within the 3D model? Okay, so that's a pretty good question. This situation has come up on a few projects now. There are actually a few solutions to this. So using the 4D software, we were able to create and add basic shapes to the 4D model. As well, we can import shapes from places like SketchUp and add them to the 4D model. One example that comes to mind on one project, we had a tank install task in the schedule, but the tank wasn't modeled. So we were able to add the tank to the 4D model, and furthermore, we referenced the tank drawing and were able to match the dimensions of the tank in the 4D model. All right, just looking through the chat box here, it looks like we've got another question. The question is, has Trillium Advisor Group found that 4D has been able to mitigate some of the issues caused by COVID-19 on construction sites? Well, thank you for the great question, and absolutely 100% we have. 4D software such as Fuser Construction Pro can allow for virtual site walkthroughs, which mitigates the need for personnel to be on site physically. On a recent project, we had an interesting dynamic, and I'll give you a bit of background on the scenario. The project was an addition to an existing processing plant, and the owners did not want to shut down the plant until they absolutely had to in order to start construction on the addition. The other problem was that they also didn't want any construction personnel in the building. Essentially, the owner did not want to risk their workers contracting COVID-19. This was very problematic, as how do you plan a job, essentially one that needs to be executed as quickly as possible so that the owner can start getting revenue again? The solution was to 3D scan the existing infrastructure, import the point cloud into the 4D software, and plan and schedule the work accordingly. Well, it looks like we're roughly 26 minutes into this webinar, so I'll take a look at the chat box here and try and answer one more question. Well, here's another good question. The question is, have you run into any issues when making the connection to the tasks in the schedule to the applicable 3D model components? So yeah, we definitely have. We've come across some fairly broad tasks in the schedules. Sometimes the task is fairly specific. For example, the task could be install vessel number 5607, but that vessel number isn't located in the 3D model metadata. What's been helpful in the past is to ensure that you have access to the construction information or drawings and have a good line of communication with the scheduler. Another lesson learned, and perhaps some advice I can pass along to ensure the accuracy of the attribution, is just ensure that the company you choose to do the work for you uses someone with a construction background as well as someone who has a strong scheduling background. All right, awesome. So yeah, a lot of great questions today. Again, I just want to thank everyone for joining me. Hope everyone has a great day and stay safe out there.